Alright, next we have here with number 5, the horse problem. And this is similar to the problem in class where we worked with a cube. So we want to pay attention to the difference between things that are measured in one dimension, for example, centimeters, things that are measured in 2 dimensions, square centimeters, and things that are measured in 3 dimensions, cubic centimeters. Let's take a look at that cube from class again, though this one may be a little different. In one dimension, the small cube's width is 2, the large cube's width is 8. Now that's a linear factor, that is something you would multiply by. A linear factor of 4 times as big. 2 times 4 equals 8. So the linear scale factor is 4 times 4. Therefore, anything measured in, for example, centimeters, which is one dimension, will be 4 times larger in the large cube and 1/4 as big in the small cube. So the height is 2 in the small cube. The height will be 2 times 4, which is 8 in the large cube. The perimeter of the base is 2, 4, 6, 8 units in the small cube. And since you measure perimeter in centimeters, which is a one-dimensional unit, if it was 8 for the small cube, it will be 8 times 4 in the large cube. 8, 16, 24, 32. Anything in one dimension will be 4 times greater. But what about 2 dimensions? Alright, let's take a look at something that would be in 2 dimensions, like area. Well, for this small cube, the area of one side would be 2 times 2, which is 4 square centimeters. For the large cube, a single side's area would be 8 times 8, which is 64 square centimeters. Now look back at that linear scale factor again. Is 64 4 times greater than 4? No. It's 16 times greater than 4. So when we're in 2 dimensions, we can't use the linear scale factor anymore. We'll have to use the linear scale factor squared. Just times 16. Because now we're in 2 dimensions. If the scale factor was 4 in 1 dimensions, then it will be 4 squared in 2 dimensions. Let's check it for all 6 sides. For all 6 sides, if one side's area is 4, then 6 of those sides will be 4 times 6. The surface area of the small cube will be 24 square centimeters. If the linear scale factor was 4, and we're in 2 dimensions, then we'll have to multiply this by 4 squared to get this answer. 24 times 4 squared is 384. Anything in 2 dimensions in the larger cube will be 16 times greater than the corresponding region of the smaller cube. In 1 dimension, everything was 4 times greater. In 2 dimension, everything will be 4 squared times greater, or 16 times greater. And then, as you might have guessed, in 3 dimensions, it's going to be 4 cubed times greater. So in 1 dimension, in 2 dimensions, in 3 dimensions, to get from the small cube to the large cube, we'll multiply by the linear scale factor. We could call it f. In the case we just did, that was times 4. Again, to get from the small cube to the large cube, if you're in 2 dimensions, you'll have to multiply the area times f squared. an example we just did, that was times 16. And if you want to figure out the three-dimensional region of the large cube, then if you know the small cube, you'll have to multiply times the linear scale factor cubed. In our example, that would have been times 4 cubed, which is times 64. Now with 3 dimensions, this often refers to mass or is related to mass. You can think of it as weight. 2 dimensions is area, which is a flat surface. How many square units fill up a flat surface? And 1 dimension is basically length. That length can go through 3 dimensions, like your waist measurement. When we put a paper ruler around our waist, it's going through 3 dimensions, but it's measuring something that's 1-dimensional, like the number of centimeters or inches. For our horse, then, the miniature is 34 inches tall, whereas the American Quarter Horse is exactly twice that at 68 inches tall. That is a linear measurement. The large horse is 2 times greater. So everything in 1 dimension will be twice as big for the American Quarter Horse versus the miniature. And when you square that, everything in 2 dimensions will be 4 times greater. And when you cube that, everything in 3 dimensions, like the space it fills, the mass, or how much it weighs, the volume of the contents of its stomach, will be 8 times greater. Alright, so let's attempt these questions A through D. For these first 4 problems, every question is asking about things that can be measured in 1 dimension. Therefore, the quarter horse will be 2 times taller. The scale factor, the linear scale factor, is therefore times 2. Width is something that would be measured in inches, so that's also 1 dimension, so that will be 2 times wider. And the length of the horse is also something that's measured in inches, so that's 1 dimension, so that answer is also 2. Everything that's measured in 1 dimension will be 2 times greater in the American Quarter Horse. The length of its nose, 2 times greater. The distance between its eyes, 2 times greater, etc. For the amount of material needed to make a blanket, we're talking about covering a surface area of the horse. We're talking about 2 dimensions, square units. So our scale factor will be times 4. And anything that's measured in 2 dimensions, square units, for the small horse, will be multiplied by 4 to get the equivalent amount of space area for the large horse. Alright, so in this problem, if the miniature horse uses 6 square yards, we'll have to multiply that by 4. The American Quarter Horse will use 24 square yards of cloth for its blanket. For this question, if the miniature horse drinks 3 liters of water a day, then how much will the quarter horse drink? Well, this is water filling space in the tummy, so it's 3 dimensions. Liters is a 3-dimensional unit. So for this problem, anything that's measured in 3 dimensions for the small horse will be multiplied by 8, the linear scale factor cubed, and that will give you the corresponding volume for the large horse. Alright, so 3 liters for the small horse gets multiplied by 8. The large horse would drink 24 liters of water. Similarly, this question is asking about something that's 3-dimensional. How much the horse weighs corresponds to how much mass it has, how much 3-dimensional mass. So if the small horse is 80 pounds, the corresponding size of a large horse, which is proportional, will be multiplied by that linear square factor cubed. the three-dimensional scale factor, which is 24. 80 times 24, 1,920 pounds. This concludes our discussion about one-dimensional, two-dimensional, and three-dimensional scaling. Next video, we'll take it from there on the review assignment.